Okay, today we are going to take a look at graphing quadratics. We're going to look at basically just the characteristics of a quadratic and how to graph a basic quadratic. So this is a linear function, and I wanted to talk about a parent function and their transformation. So parent function is the graph of a function before we make any changes to it, basically. So in a linear equation, my parent function is y equals x, and it just is this basic graph. Over here, this is y equals -1/2 x, and what we've done is we've changed the slope and we've made it negative or flipped it over the x-axis. So this is just an example of a parent function and a transformation. Okay. The quadratic parent function, and remember a quadratic is a polynomial with a degree of 2, is just y equals x squared. We make no transformation to it. So if I was to sub in -2 for x and complete this chart, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So I'm going to graph this function, and then I've got the point -2, 4, the point -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So this graph looks like this. It's got this nice little curve thing, if I could get the points on there nicely. And we actually call that a parabola. Okay, it's a conic section. So this is our basic graph of that quadratic. Okay. Other quadratics are based off from this and the changes that we make. And we're just going to look at two basic changes today. So I want you to go to Desmos, actually do it please, and I want you to graph these 3 equations. And this looks more like 1/2 x squared, okay? And I want you to notice a few things. Take some time to do it, and then pause the video, and then go on. Okay, so on this first graph, we have in red graphed our parent function, y equals x squared. In blue, we have graphed y equals 2x squared. And I want you to think about the slope of a line, okay? When we had a slope like 2, that made our line steeper. Notice that it makes our quadratic steeper as well. So instead of going over here to this point, 1, 1, our point here is 1, 2. Okay. Our point, instead of being -1, 1, which it is on our parent function, that first point, on the blue, on the graph of y equals 2x squared, I've got the point -1, 2. Okay. So notice that I multiplied my y values of my ordered pair by 2. Now let's look at the other graph. Okay. All right, so on this graph, again, my parent function is in the red, the y equals x squared. and the green is the y equals 1/2 x squared. So again, our parent function, we have the point 0, 0. And of course, in the green, its corresponding point is 0, 0. Here, we have on the parent function, we have the point 1, 1. On the corresponding part on the graph, so when x is 1, in this case, y is actually 1/2. Okay? And the parent function, we have the point 1, 1. And on the transformed graph, we have the point -1, this should be -1, 1/2. So what I want you to notice on those parent functions, when we have a number in front of the x squared, when we're transforming the parent, what we're doing is we are multiplying the y value by whatever that is. So if we have y equals ax squared, we're going to multiply our y value from the parent by a. And that's just the y value. So go back to Desmos and graph these and make the same kind of observations. Pause the video until you're ready to go on. So in our red, we have our parent function, again, y equals x squared. In our purple is y equals x squared minus 4. And here, what I want you to notice is I've taken all of my points and I've moved them down 4 places. So this point comes down 1, 2, 3, 4. Okay. And then this point here moves down 1, 2, 3, 4. This point here moves down 1, 2, 3, 4. So what I've done is I've taken my point, and if you think back to last year when you looked at transformations, okay, I've taken my x value, I've kept it the same, my y value, I've subtracted 4. So that's my transformation. All I've done is take that y value and moved it down 4 places. Let's look at the next example. In the red, again, is our y equals x squared. Our black is y equals x squared plus 3. What I want you to notice here is from our parent function, we've moved our graph up 3 places. So that's up 3 places. This point is up 1, 2, 3 places. This point is up 1, 2, 3 places. So we're going from our x, y to x and y plus 3. If you think about the transformation, we've taken all of those points from our parent function and we've changed the y value by adding 3. So I just want to summarize really quick. In our parent function, if I have x, y, okay, and I have the equation y equals ax squared, so I'm doing something here. This shifts our parent function points to x and a times y. So if you looked at your parent function, if you had x, y, it was -2, 4, -1, 1, 0, 0, 1, 1, etc. The ay, okay, so if we have a coefficient in front of that x squared, we multiply that by that coefficient. So this would be 4a, 1a, 0a, and 1a, no matter what that is. Okay. If I have the next, and I have y equals x squared plus k, okay, we're going to transform by adding or subtracting k, whatever it is. Okay. So x and then plus or minus k. So this, going from here to here, would be 4 plus or minus whatever k is, 1 plus or minus whatever k is, 0 plus or minus k, 1 plus or minus k. So that's just some basic transformation of the quadratic. Now I want to take a look at also some basic characteristics of the quadratic, and we're going to start with the vertex. And the vertex is basically another word for a turning point. It's where the graph changes direction. So right here is where that vertex is. It is, in this case, the lowest point on the graph, so this is a minimum. This point is the point 3, -1. So that's my vertex, 3, -1. And it's going to be an important point, because what I want you to see is that when you draw a vertical line through this point, it folds in half and the points are reflecting over it. So if I go here to here, I've got 1 unit, here to here is 1. If I come up here, 2 units, 2 units. So they reflect over each other, so we call this the axis of symmetry. Okay, it is a vertical line, so it's going to be x equals whatever your vertex is, the x value. So the equation for your axis of symmetry is x equals 3. Okay. Recall from linear equations that your x-intercepts are where the graph crosses the x-axis. Okay. So it's going to cross right here and right here. So this is the point 2, 0 over here, and this is the point 4, 0. And those are my x-intercepts, 2, 0, 4, 0. Now we have other names for those. We'll call them roots from time to time, and we'll call them zeros. So all 3 of these words are interchangeable, and you need to understand that they're the exact same thing. Last is our y-intercept, and our y-intercept is where it crosses the y-axis, and in this case it is the point 0, 8. I've got more characteristics of this quadratic. I'm just going to write the vertex again because it's kind of important to the domain and range. So again, my vertex was 3, -1. Okay. My domain is all of my x values. So my domain is where this graph goes this way. This graph is going to go on forever and ever, and it's going to get wider and wider. So it is going to hit every conceivable x value. So we say that this goes, and we use parentheses. There's two different kinds of notation, from negative infinity to positive infinity. So on a graph, this is negative infinity. If I keep going out this way, if I go out this way, it goes to infinity. Okay. We can also say that it's all real numbers, whichever you want to use. I don't care which way you do, just recognize that there are two different ways that you can write this. Okay. Now the range is all of my y values. What I want you to notice is that because my arrows point up, it's never ever going to go below the vertex. Apologize for that. So it'll never go below the vertex. So my lowest value is the y. Okay. So it will never go below -1. So we use a brace to say -1, and it's going to go all the way up to positive infinity. If it would open down, it's going to go to negative infinity. So this is going to go from -1 to positive infinity, or we say y is greater than or equal to -1. And we use this, and it means all y's such that y is greater than or equal to 1. This brace going this way is the same as saying y is greater than or equal to 1. Okay, the parenthesis says that that's not included. So a parenthesis, if it was going this way, would be just greater than. And we'll talk more about that in class. I'm actually going to save intervals for increasing or decreasing till when I can see you in class. So we're just going to skip that for now. On the last page of your notes is another graph, and it's asking you for all of those key characteristics that I went over. Please take a minute, pause the video, and see if you can do that on your own. And then I will go ahead and then show you the answers. So here are your answers. So I want you to check for notation. I want you to check to make sure that you have these correct. Okay. And again, we'll talk about intervals for increasing or decreasing in class. So in this video, you should have learned all of these characteristics of a quadratic. I know this was a long video for tonight. Hang in there. I appreciate you hanging in there. I don't like them to be this long. But you guys have a math-tastic day.